Right, so let's start. So the topic is usability of intelligent systems, and as a case example, I'm using search engines. So this is now from the beginning of my dissertation, 2014, 2015. So how many of you have used any intelligent systems today? Like interacted with some AI stuff? Maybe with a system that models you, has some kind of a personalization, like learns from you, tries to understand you, and so on. So that's becoming more and more common every day. So like what the main topic here is kind of how do we have or keep those systems usable? Like when we want to do something, we can actually achieve it. The system doesn't do something strange. It's not out of control, and so on. So first, let's start a bit about like general usability. So let's think about the hammer, which is a nice tool that I guess all of us have used. So it has nice, interesting usability history. So it started maybe 3 million years ago. People were just using rocks as a hammer, and it took something like about 2 million years for people to figure out that hey, maybe we should actually have this handle here. So it's actually easier to use. We can use it for its purpose in a much more comfortable way. We can do what we want to do with it, and it's easier for us. And nowadays, if you look at the hammer, it's kind of very sophisticated, quite far away from the original pure hammer that was the rock. All right. So what is usability? So usability is defined so that you have some kind of a system that you use to do some kind of a task. So you have kind of three parts in the system. So you have the user, the tool, and whatever the user wants to do with the tool. And what makes a system usable is that like you can actually use that system for achieving those goals that you have. Right. And a second like background concept that I would like to introduce is mental models. So what are these? So a mental model is user's internal representation of the system. So this kind of corresponds to, if you think about the intelligent system, that has a model of the user model, but actually the user also has a system model in its mind. And why do we have these mental models? Is that they allow us to use these complex systems, because we can use these mental models to predict what's going to happen if we would do this or that kind of a thing with the system. So for example, when we have this screwdriver, we can have a mental model that, yeah, if I turn it right, then the screw will also turn right. And then I can use that mental model for deciding what to do in order to achieve the goal I want to achieve. And this is kind of model predictive control, if you know that term. Right. And the key thing here is just that, you know, in order for any system to be usable, the mental model of the user needs to be somehow aligned with the actual behavior of the system. Like if the user has a completely different mental model and tries to control the system with it, then probably the results will not be anything that the user wants to achieve. All right. So now let's look at another history of another tool, and this is now the usability of the statistical modeling that we use. So about 300 years ago, there was this guy, Bayes, who invented this Bayes rule. This is actually from the same article. So maybe not very usable. You need to read the article and understand the maths and implement it yourself and so on. So it's very, very complex to use these statistical tools back then. Maybe some tens of years ago, we started implementing these statistical models using computers, and we might have these rudimentary systems so that we can automatically use these statistical models to get to the goals that we want. And maybe now or in the future, we might have these even better ways to use these statistical models so that we can just take the model and very easily apply it to the real world and extract the information from the data that we want. So for example, this is a screenshot from a user interface for a web search engine that we used in our research that allows you to visualize the statistical user model and interact with it. So quite a far leap from the original Bayes' formula 300 years ago. Although, of course, it's a bit faster than with the hammer, so we didn't need to wait for 2 million years to figure out that, yeah, we can actually do something better than just pure math. All right, so now let's think about this recommender system. So it's usability. We have now these background concepts of like usability. So let's try to apply this here. So the task now here is that the user wants to find some interesting items from some large catalog of items where only maybe a small part of them are actually interesting. And what the process is that, well, the system constructs some kind of model of what the user wants to find. Then it will use that model to rank the items in the catalog and display the best items to the user. And after that, the user will then maybe change or maybe give some more feedback that, yeah, I wanted to find a cat, but not a brown cat, I wanted a black cat. And after I want to see the black cats, maybe, but I only want the kittens and not the large ones, and so on. So the user is kind of giving more feedback and improving the user model bit by bit until the user is satisfied with whatever the search engine gives us. Right? All right, but there's the interesting point here is the number 3. So if the user is not satisfied, allow the user to give further input. So how do we go about that? Right. So we had this theory that the system is usable for a task and so on. So how is the user able to give feedback? How is the user able to change the user model within the system? What kind of tools does the user have for that? So here is like one example. Like if you go today to Google and you search for AIHelsinki, it might give you this kind of recommendations that maybe you actually want to say this, or maybe you also want to say this. So that's one way to allow the user to give or make changes to the user model. Another example might be this kind of visualization of the model. So in here, you might drag the keywords around, give them higher weights, lower weights, add more keywords to the model, and so on. So these kind of ways the user actually has to change the user model. Right. So then, like we had here these 3 points, like we might need to think like what kind of input can the user give, how is the input given, and how can the user know what input will improve the results. These are maybe the 3 most important questions. And the first 2 are relatively simple. So for example, the user can give search keywords as feedback. The user can give relevance feedback to different items as a feedback, and so on. And the methods to give that are like keyword boxes, or you can drag things around in the interface. So that kind of things are relatively or easy to answer and solve. But the third one is a bit more complex. So how can you know what kind of feedback you should give to get the answers you actually want out of the search engines? And now this brings us to the mental model concept that I introduced. So how can we align the mental model of the user with the actual behavior of the system? And this is actually not precisely trivial when the system is very complex, as is with these intelligent systems that use machine learning to infer what you want. So it might be, or it might commonly be the case that the user has some kind of a representation in their mind, like maybe this system behaves like this, whereas the actual system behaves in a completely different way. So how can we solve this? And essentially you have 2 options. So the first one is you either change the mental model of the user so that the user has a better representation of what the system does, how it behaves. And the alternative is that you change the behavior of the system so that it better matches the mental model of the user. And I guess these are maybe the only 2 ways to go about this. Okay, so how could we actually implement this in practice? Okay, so the first point, how can we allow the user to better calibrate her mental model with the system behavior? And one approach here that we took is that we predict what different feedback from the user will cause, and we will visualize them to the user before the user has to decide the action or the next action to take. So for example, in this visualization, the user is thinking about giving feedback, relevance feedback to the keyword model. And it might be that if the user would give low relevance feedback, what would happen? Well, we can predict that. We have the machine learning model. We can take like one step back prediction and show that, okay, this kind of stuff would happen. And the same thing, like if the user would give high relevance feedback, we can also predict what's going to happen in that case. So in that way, the user kind of has a way to see the future one step ahead. And in that way, be able to understand better, if I would do this or if I would do that, well, what would happen? And because of this, the user then has better tools for calibrating her own mental model and understanding a bit better how the system behaves. And the next, or the alternative was, how can we make the system behave in a more intuitive way? And this is maybe a bit more tricky. But one approach to doing this is that, like, instead of treating the observations from the user simply as pure data, so we just have, when the user gives feedback, we just have one more observation, and we relearn our machine learning models on that data, and we just display whatever comes out. But instead, what we could do is that we could treat the user's feedback as requirements for the next state of the model. So, for example, here's one example. So I had given some previous feedback on the search model, and then I gave one more feedback, and I said, I want nuclear power plants to be very relevant for my search interests. But what actually happened was that it was nowhere to be found. It was not even among the top keywords predicted by the model. So what I actually, as a user, what I would expect is that, if I say to the system, do this, then the system will actually try its best to do precisely that. And what I can do is that I can then treat the user's feedback as a requirement for the next state of the model, and I can optimize the data that is needed for the machine learning model to give out such predictions. So it's kind of like a taxi driver. So you just say, I want the model to look like this, and you have this helping hand kind of giving those data items to the machine learning model in the background. Question.
Short question, do you actually measure timings of people's responses, because they are actually reflecting the cognitive effort that is included in the UI?
Yeah, that's an interesting question. So the question was, do I measure the time it takes for the user to give feedback? But at least in this line of research, we didn't measure that, but that would be interesting. It's actually related to another line of research I've been doing, but maybe we can discuss about that offline. So that's more about learning these cognitive models of users. Okay, but yeah, we had these two approaches. So either we allow the user to calibrate their mental models, or we kind of make the system behave in a more intuitive way. Then again, one more slide of theory. So user errors. So what are these? So users make various kinds of errors, and maybe the two most relevant ones are unintentional errors and mistaken actions. And unintentional errors are like typos, so you just didn't actually mean to do that action, but you did it anyways. And mistaken actions are like you thought that whatever you did would cause some kind of an effect, but it actually didn't cause that kind of an effect. So for example, if you accidentally turn the screwdriver the wrong way, then that's kind of like an unintentional error. If you search for an apple in Google and you want to find like these things to eat, but you find these things to compute, then that's kind of like a mistaken action. And what do we have to kind of help the users recover from this is feedback. So there are different ways of giving feedback to the user from different kinds of errors. The one you're probably most familiar one is spell checking. So you write something and it highlights, hey, maybe you didn't actually want to type this. So that actually helps for both kind of errors. So it might be that maybe you made a typo, or you just thought that this word was spelled like that when it actually wasn't. So feedback. So now let's think. So we have these machine learning systems, but do we have any spell checking for them? Can we actually help the user recover from errors? And I actually tried this with Google this morning. So if I write like AIHelsinki seminar, it actually find out that I probably didn't mean AIHelsinki, but it was AIHelsinki, and it tells me that maybe you didn't mean to type that. But for example, if I type something that doesn't make sense to the search engine, I want to find a warm, sunny beach holiday result in the middle of the North Pole, like that. Like as a human, it doesn't really make sense. Like there's no such thing. But Google doesn't realize that, but it just gives you something that maybe makes sense. But what we could do is that so we would evaluate all of the data we have from the user, and we could fit a model to that and estimate, what part of the feedback that the user has given to us makes sense. And we could also do this by visualizing the entire data set from the user, or at least the most relevant parts, and we can then highlight from that, which part of the feedback doesn't actually belong in the set. So, for example, in here, I probably wanted to find something related to exploratory search engines and such, but the system then finds out that I have this feedback on racing cars and financial planning, and it doesn't really fit in. Like I can't fit a good model that explains all of this data. So instead, I could highlight to the user and ask, like, did you actually mean this? Did you mean to give this feedback, or is this just an error? So that's kind of like a spell checker, but for machine learning systems that users can interact with. Right. So I have a small demo. Let's hope that it works. Right. So unfortunately, I didn't anymore have access to the original search engine code, so I just wrote my own very small one. So let's see. So I search. Okay, let's start with the simple one. So we have no bells, no whistles. So this is actually this is Google essentially. You just go there, you type something in, and you get some results. And then you can check these results whether they are what you want or not. And you know what? And if you want to change your query, then what do? You'll just maybe go in here and type something else. So that's essentially the only way that you can affect how the system behaves. And the next level is that, okay, so maybe we could visualize the model to the user. So we can see that, okay, so this is the feedback you have given to us, and this is the model. So the model says that printers are important, and maybe print, laser, those are relevant, and then there's some other keywords, some other features that are also relevant. And in this case, I can then maybe realize that, hey, actually it was laser printers that I wanted to find, and not just printers, because I can see the word. It's easy for me to realize that, that's the thing. So I can maybe take the laser and I can say that, also do the laser thing. And then maybe the results will then reflect this reality. And this might be an easy way for the user to go forward in using the system. But of course, there's the thing that, when I'm thinking about, HP, should it be relevant or not? I can't really tell what's going to happen. Like, can any one of you predict what's going to happen if I would give different kinds of feedback to the system? Probably at some level, maybe, but something's going to happen. Who knows what? But what we could do is that we could actually just show those predictions. So that's the thing. So let's say I take this word postscript, and so I can actually see that it will affect some of the keywords positively and some of them negatively. So, or maybe and I can also see like that the results I get, they would change, and I can kind of see in which way would they change if I would give different kinds of feedback. And this might now help the user kind of choose what kind of feedback to give in a better way. And in here I can also see that some of these keywords, or the laser keyword here, is actually marked as kind of outlying. So the model cannot well explain like why does laser have high relevance if all of these other keywords have low relevance. Like there isn't just a good model that can explain all of that. And I can kind of see that this is now an outlier, and maybe focus my attention here and think about whether I really wanted to have laser be relevant or not. And then I could also have this added control. It might not be very visible because it's mostly active when you have a larger amount of feedback in the background. But what's actually happening is that, like when we have this control, it will actively try to give the kind of feedback that will cause your most recent feedback be well represented by the last models. Let's say I will give contradictory feedback. So I have both said that Apple should be relevant and should not be relevant. So actually now what the control did, because this one is the most recent feedback. Like this one is actually now well predicted by the model, but the feedback I gave previously is not equally well predicted. And this was because of the added control. Like if I didn't have that, then both of these feedbacks would have been just equally likely. Because if you have like +1 and -1, your model will predict like half or no 0. Right. So that was the demo. I think I still have like 9 minutes for questions. Thanks.